I think this is where we left off on the notes, where we were talking about the properties of ionic compounds. Let me grab a set of notes so I'm looking at what you're looking at. So this would be on the second page, letter F, I believe. Is that where we left off?
Yeah.
Okay. Sometimes it's good I don't say the things that go through my head. All right. So the properties of an ionic compound, okay? Really, the basis of an ionic compound in the first place is that a metal atom will give an electron away to a non-metal atom, okay? So if you have an ionic compound, there's always going to be one metal, one non-metal. And when I say always, I mean always usually, okay? There's always exceptions to things in chemistry, and when I say always exceptions, there's usually exceptions. There's exceptions to the rule that there's exceptions as well. So anyway, I can't say anything like for sure ever in chemistry, okay? There's always exceptions to every rule that I give you, which is unfortunate, but I guess that's reality. I don't know. Or we have no idea what reality is, really, and we're just making stuff up, which could be the case. So a metal atom can transfer an electron to a non-metal. That was for you. The resulting cation and anion are attracted to each other by electrostatic forces. Okay, so what happens here, basically, is that a metal atom will give an electron away to a non-metal atom. So now, this metal atom has a positive charge. The non-metal atom has a negative charge, okay? So you've got kind of this awkward situation here. Like, you could almost make a movie about this where a thief comes along and steals something from someone, but because he stole that something, now they are attracted to one another, and whoops, they stick together and form an ionic bond, okay? I just feel like that's like a movie script or something. Anyway, so basically, because, let's say that we've got sodium chloride as an example here, all right? So you've got Na, well, okay, let me draw this out, and let me use the red. We determined that red works better, right? So you've got Na, right? Sodium has one valence electron. Then you've got chlorine, which has 1, 2, 3, 4, 5, 6, 7 electrons. Now this is a pretty good match, right? Because sodium would like to get rid of one valence electron so that it can be more like neon, okay? Chlorine would like to gain one so that it can be more like argon, okay? So that's a pretty good match, right? The sodium can give its one electron away to the chlorine, and that's a good situation, right? Yes, sir. Is that for the next activity?
This one and this is the next one.
Sure. Well, maybe. I'll talk to you about it later.
Right.
Sorry, I don't know for sure yet.
All right.
Okay, so what's going to happen here essentially is that this electron travels over to the chlorine, right? So sodium is going to give that electron away. So then what you're going to end up with, the sodium just gave up an electron, so now what charge does it have? If it gave away an electron, no, it was neutral to begin with, right? So now it gave away an electron. Now it's going to be a 1 plus, right? So this is a positive charge. The chlorine just gained an electron, so now it's a negative charge, 1 minus. Well, what happens when you put a positive and a negative next to one another? They attract, right? Opposites attract. You've heard that saying, all right? So what happens here is these two are attracted to each other. They come together and they form a bond, and that's where you get sodium chloride. That's where table salt comes from, okay? So that's kind of the idea behind an ionic bond, all right? Is that idea that you get this cation and anion, they're attracted to one another, they form a bond, okay? But before that happens, there has to be a transfer of electrons from one to another, okay? That's how an ionic compound gets formed. Oh, I didn't realize that was sodium and chlorine down there. Okay, so that's how it forms. Now, let's do some other examples here. Are these on your sheet? Yeah, but then it says, okay, that's it. Examples of ionic compounds, okay? So you've got Ca, don't write this part, okay? You can just write what it forms. So Ca2 plus F minus is going to form calcium fluoride, which is CaF2 is the formula, okay? Now, I'm going to show you today how to get from here to here, okay? How to get from the ions to the formula. You don't need to know that yet, Okay, so calcium fluoride is one example of an ionic compound. Another example, you put magnesium and nitrogen together, it forms Mg3N2. That's called magnesium nitride. All you need to be writing here is the formulas and the blanks, because that's all you really have room for. Okay. Where it says for letter G, examples of ionic compounds, CaF2 can go in that first blank. The Mg3N2 can go in the second blank. And then the last one here, SNO, that's tin 2-oxide. Okay. And again, by the time we're done with this unit, hopefully you will know how to name and write formulas for these things. Okay, so then the last blank would be the SNO. Okay, so the question is, where do these formulas come from? How do we know that this is CaF2? That when I put calcium and fluorine together, it forms 1 calcium and 2 fluorines. How do I know that? How do I know that it takes 3 magnesiums and 2 nitrogens to form magnesium nitride? Okay, so here's how you do this. This is, now we kind of skipped over the, oh, I'm sorry, let me do the sodium fluoride example for you real quick, okay? I'll just do that right here. So you see where it says sodium fluoride example on your notes? Okay? So what you do here is you figure out what ions are going to form, okay? So if you've got sodium and fluorine, what ion will sodium form when it forms an ion? Probably need to back up a step, okay? How many valence electrons does sodium have? 1. So what is sodium going to do in order to be like a noble gas? What's its strategy? It could gain 7, right, and become like argon. Or it could lose 1 and become like neon. That's probably easier, right? Okay? So if it's going to lose 1, then the sodium ion is going to be Na+, right? You lose an electron, you become positive. Okay? And then fluorine is the other part of this. Now, how many valence electrons does fluorine have? 7. Let me write that up here. 1, 2, 3, 4, 5, 6, 7. So what's fluorine's strategy for becoming like a noble gas? Gain 1 electron, right? All it has to do is gain 1 and it will be like neon. Okay? So if it gains an electron, it's going to have a negative charge. Electrons are negatively charged. If you gain 1, you'll have a negative charge. All right? So you've got Na1 plus, F1 minus. Okay? That's kind of a nice match, right? Because a 1 plus and a 1 minus, you put those together, and what's the overall charge? 0, right? Remember we talked about the other day, this is just algebra, right? If you have a 1, or I guess I don't need to write the plus necessarily, it's kind of assumed. But if I have a 1, and I add that to a negative 1, then that's going to equal 0, okay? So this just ends up being NaF, all right? Good. Yeah, well, we're going to do a lot more examples, so if it doesn't completely make sense yet, that's okay. I guess I need to erase all of this now. Okay, now we're going to do an example with barium and chlorine, okay? So, we want to write the formula for the ionic compound that will form between barium and chlorine, okay? Now, on your notes, it's a little bit nicer. It actually tells you already what charges they'll form. How do I know barium's going to form a 2+ charge? Where is barium? Second column. So how many valence electrons? 2, okay? So it's number 56. If it loses 2 electrons, then it can be like xenon, right? So if it loses 2, it would have a 2+ charge because it's losing 2 negative electrons. No, it'd be a 2+, yep, okay? So that's where the 2+ comes from that's on your notes, okay? Same thing with the chlorine. Chlorine is in group 17, okay? It's actually number 17 as well, but it's in group 17. So if it gets 1 more electron, then it can be like argon, okay? So all it needs to do there is just gain that 1, and then that would have a 1- charge, okay? Now, if I put a barium, a Ba2+, whoops, I reverted back to black, sorry. So I have a Ba2+, and I have a Cl1-. If I put those two together, is that going to give me a neutral compound? No, that's not quite going to work out, is it? Okay? So what I need here, what if I have 2 chlorines? Okay? So if I combine 1 barium with 2 chlorines, then I have a 2 plus, and I add that to a -1 plus another -1. That's going to give me 0. Okay? You have to combine these things in a way that you end up with a charge, overall charge of 0. Okay? Because if this still has, when this barium combines with that chlorine, it's still going to have a 1 plus charge. So it's still going to be looking for something that has a negative charge until it finds this. Okay? So then what you're going to end up with is 1 barium, 2 chlorines. Okay? So I'm going to write that as BaCl2. This subscript right here basically tells me how many chlorines there need to be in this compound. Okay? Because I need 2 and 1 barium. So this is kind of an understood 1 right here. We don't write the 1, but it's kind of understood that this is 1 barium, 2 chlorines. You're just trying to make it equal 0. Yeah, the charge, the overall charge of the compound needs to equal 0. Okay? Okay. So another way of thinking about that, determine the common ion for the element, which we already did that, okay? Write the positive ion of the metal first, and then the negative ion. So you've got Ba2 plus, Cl minus. We already talked about that, okay? This is already written in here for you, I think. Okay. Use the crisscross method. Okay, now let me show you a little shortcut here that you can use, okay? You can just kind of think about this and understand it for most of these, okay? But if you want to save yourself a little bit of time once you do understand it, this can be kind of handy. So I've got a Ba2 plus, I've got a Cl1 minus, right? If I take the numbers of my charge, the 2 and the 1, and I crisscross them, in other words, whatever's up here becomes a subscript down here, whatever's up here becomes a subscript down here, that's going to give me Ba1 Cl2, which is exactly what we said, okay? So that's kind of a nice little shortcut, right? That will work every time. Now, sometimes you might have to reduce, right? If this is a 2 and a 4, you need the simplest whole number ratio, so you'd have to reduce down to 1 and 2, okay? But yeah, it will work. Because I wanted you to understand why. Well, no, that doesn't, it makes it easier, you're right, but it doesn't explain the concept. Okay, I want you to understand you've got a barium ion and you've got 2 chloride ions. They have to go together to form a 0 charge. I want you to understand that part, and then I'll give you the shortcut. Okay? Yeah, so that's a nice little shortcut that you can use. Okay, so that's the crisscross method, and then you end up with BaCl2. And it says down here, reduce if necessary. That's what I just said. Sometimes you might have to reduce. You want this to be the simplest whole number ratio. You guys remember us talking about empirical formulas last semester? Okay? You need the empirical formula every time for an ionic compound. Okay? It always needs to be the simplest whole number ratio. All right. So now some examples, which are the practice problems that you have here. And actually, these are multiple choice. Okay? So I guess we're easing you into this here. Sodium and chlorine, right? Now, to make it a little bit easier, I've already given you the charge on these things. Okay? So the sodium's a 1 plus. Oops, sodium and chlorine. That's not right. Ah, nuts. This does not match, does it? Okay, tell you what. I'm just going to show you these quickly so that you get an idea, and then we'll do the actual practice problems. I'm sorry that I didn't give you a space for this on there. So let's say we've got sodium and chlorine, okay? So what we need to figure out first is the charge on each of the ions, okay? What's the charge going to be on a sodium? It's going to be a 1 plus, right? Did it again. So Na is a 1 plus, okay? What's the charge on chlorine? 1 minus. Crisscross, and you end up with NaCl, which we already did this one, right? Okay, so there's that. Number 2, cesium and bromine, okay? What's the charge on cesium? Gotta find it first. Cesium is Cs, What group is it in? In the first group, so it has one valence electron, so it's going to form the charge 1 plus. Okay, everything in group 1 is going to form a 1 plus charge. CS is a 1 plus. What about bromine? Does everybody see that? Bromine is in the 17th group. Okay, so it needs one more electron, so it's going to form a 1 minus. So 1 plus 1 minus gives me CSBr. These aren't that bad, right? Okay, aluminum and oxygen. What charge does aluminum form? 3 plus. It's in group 13. It has 3 valence electrons. It's easier for it to lose 3 than it is to gain 5. Okay, it can lose 3 to become like neon, or gain 5 to become like argon. It's going to lose 3 and form a 3 plus charge. What about oxygen? 2 minus. Okay, this is the trickiest one we've had so far. Take the numbers, crisscross them, and what's your formula? Al2O3. See how that works? No, not necessarily. Now you can think about it that way, right? Because if I have an aluminum here with a 3 plus charge, and then I have an oxygen with a 2 minus, that just doesn't work, right? So then I bring in another oxygen. Well, now I have too many negative charges, right? So now I have to bring in another aluminum. So now I've got a 6 plus charge over here, 4 minus over here. So if I have one more oxygen, then that would balance out, okay? It's kind of like the milk and the cereal thing, right? I always, put in too much milk, and then I have to add a little cereal, and then I have to add more milk because I added too much cereal, and, it's a vicious process. That's kind of what's going on here, right? You got one aluminum, you add another oxygen, well, that's too many negative charges, so now I have to add another aluminum. Now that's too many positive charges, so then I add another oxygen. Same thing, right? I end up with 2 aluminums and 3 oxygens at the end, which is exactly what our formula is telling us. But the crisscross method is just a shortcut, okay? And then the last one here, no, I don't think this is the last one, but the next to last one maybe, calcium and sulfur. What's the charge on calcium? 2 plus. Everybody okay with that? And sulfur? Oh, that's okay. So Ca2S2, right?
No. Yeah.
Okay, so when you crisscross here, Ca2S2, but remember we need the empirical formula. We need the lowest whole number ratio. This can reduce, right? So this is going to equal just CaS, okay? Now this is one of those cases where we almost could have saved time just by looking at the ions themselves, right? If you've got a 2 plus ion and a 2 minus ion, then obviously you just need one of those to make a 0 charge. Barium and nitrogen. Barium has what charge? Heard somebody say it. 2 plus. Nitrogen, 3 minus. Crisscross. What do you end up with? Ca3 N2. Okay? So that's how that works. Everybody all right with that? Okay. Oh, there is another one. Magnesium and phosphorus. You know what? There's no need to do that. It's exactly the same as barium and nitrogen. Okay, so we'll skip that one. All right, here's the practice ones that you have on your sheet, and all you have to do on these is just circle the right answer. So the correct formula using the following ions. What would be the correct formula for the first one? B? Are we in agreement there? Okay, that is right. So when you crisscross these, the 2 goes over here. There's kind of an understood 1 here that goes over here, so Na2S. What about the second one? A? Okay. Good. And then the last one? C. Perfect. All right, making sense? I think we are done for the day. Well, it gives you the solutions here. Yep, that's as far as we're going to go. So I'll give you a worksheet to work on this, and that'll be it.